All right. And last but not least, problem number 12. This is where the problem where the really long problem took us the longest, like 10-minute problem. I think problem number 6. This should make a little bit more sense. All right. So here, writing the equation in standard form using integers, right? So notice how we're given an equation in slope intercept. Negative 3 fifths x minus 7. Now, it's actually a little bit of what we did last problem, but here it should be clarified exponentially. All right. So remember, the first thing that we're doing is we want to convert y equals mx plus b down to ax plus by is equal to c, right? Now, again, notice the key difference here. The only key difference is that aside from not having the same variables, right, y, m, and b here, we have a, b, c over here. And again, these are not the same. Like this b is not the same as that b. Everything is a little bit different. It's just a different form. But if you notice, the key difference is that this mx is on the right side of the equal sign versus here it's on the left side. That is a key difference. So looking at this problem, I know I need to move this over to the left side to go from having the y on the left side to having both x and y. So again, how do I do that? I just move that 3 fifths x over to the other side. So I'm going to add 3 fifths x. Again, I'm going to do it to both sides because I want to get rid of this negative 3 fifths x altogether, not just the number portion, not just the variable. So 3 fifths x minus 3 fifths x cancels. So I'm left with the negative 7 on the right side. Now look, over here, I cannot combine this. So this is 3 fifths x plus y. All right? Now remember, this, even though it's the correct answer, is a big no-no. Why? Because a, b, and c are always integers, meaning whole numbers. We don't like that because here we have 3 fifths as a fraction, right? So my question to you is, and if you paid attention, how do we get rid of the denominator? Right? What can we do to get rid of the denominator? Remember, we can multiply every term, both sides of the equation, by that denominator to get rid of it. So notice how here, yes, we're multiplying, it's 3 times x, and then we're dividing it by 5. Right? So for me to do this, I can actually multiply every single part of this equation by 5. And this is why problem number 6 now should be a little more familiar. Now you know why I multiplied it by 4. Well, again, on my problem in that scenario, because I wanted to get rid of this fraction, right? And look, in me doing this, again, it's like we're giving the 5 to every single term. Notice how here, again, we're adding. That is why it's going to the first term and second term. Now, again, we did on the left side, so we did on the right side, but here I just did the whole distribution arc, right? So look, why am I doing this? Well, look, 3 fifths times 5 times x. That's what this is saying. 5 times 3 fifths times x. Plus 5 times y is 5y. And then 5 times a negative 7 is a negative 35. But again, Gons, I still don't see the point. Why are you doing this? Because we want to get rid of fractions. This was chapter 1 now. How do we get rid of fractions? We have to multiply every single term in the equation by that denominator. So look, 5 divided by 5 cancels. That's the whole point of this. So what's left? Well, 3 times x. 3 times x is just 3x. And just like that, I now have my standard form equation. 3x plus 5y equals negative 35. 3x plus 5y equals negative 35. And there it is. We're done with homeworks. All right. Again, this section is by far a really tough section. But again, take your time with it. I know problem number 7, I believe that's the one that I used a lot of calculator in. Pause the video. Go over it, please. Problem number 6 was also a doozy. It was a really hard problem, really complicated. So again, make sure you're using the steps. If you have difficulties or, if you miss some of these, don't stress about your grade. But again, use the homework help. There's only one of the homeworks out of the plenty that we've taken. So, yeah, good luck. Turn it in on time. I'll see you guys later.